Yo, yo, yo.
ਤੇ ਦੋਵੇਂ ਬੜੇ ਅੱਤਦੇ ਆ ਪਹੁੰਚੇ ਹਾਈ ਕੋਰਟ ਤੱਕ ਰੌਲੇ ਖੱਪਦੇ ਆ ਇੱਟ ਤਾਂ ਸ਼ਰੀਕਾਂ ਚ ਸੀ ਨੇ ਤੇ ਚੱਲਦੀ ਹੁਣ ਅਸਲੇ ਯੂਪੀ ਤੋਂ ਜੱਟਾਂ ਚੱਕ ਲਿਆ ਹੁਣ ਜੇਲ੍ਹ 'ਚ ਹੀ ਹੋਊ ਨੀਂਦਦਾਰ ਯਾਦਾ ਯੋ ਪਿੰਡ ਪਿਆ ਸਾਰਾ ਗੈਂਗਲੈਂਡ ਬਣਿਆ ਤੂੰ ਆਖਦੀ ਏ ਜੱਟਾਂ ਸ਼ਹਿਰ ਗੇੜਾ ਮਾਰ ਜਾ ਪਿੰਡ ਪਿਆ ਸਾਰਾ ਗੈਂਗਲੈਂਡ ਬਣਿਆ ਤੂੰ ਆਖਦੀ ਏ ਜੱਟਾਂ ਸ਼ਹਿਰ ਗੇੜਾ ਮਾਰ ਜਾ ਸਾਰੀ ਰਾਤ ਲੰਘ ਜਾਂਦੀ ਦੰਦੇ ਪਹਿਰਾ ਚਾਹ ਵਾਲੇ ਟਾਈਮ ਚੱਲਦੀ ਆ ਲਾਣੀ ਓਏ ਸ਼ੇਰ ਬੱਬਰਾਂ ਦੇ ਵਾਂਗ ਜੱਟਾਂ ਦੀ ਆਣ ਲੰਘ ਜਾਂਦੇ ਇੱਕ ਦੂਜੇ ਕੋਲੋਂ ਹਿੱਕਾਂ ਤਾਣਨੀ ਓਏ ਸ਼ੇਰ ਬੱਬਰਾਂ ਦੇ ਵਾਂਗ ਜੱਟਾਂ ਦੀ ਆਣ ਲੰਘ ਜਾਂਦੇ ਇੱਕ ਦੂਜੇ ਕੋਲੋਂ ਹਿੱਕਾਂ ਤਾਣਨੀ ਓ ਮਰੇ ਸੱਪ ਵਾਂਗ ਜਿਹੜੇ ਆਕੜੇ ਨੇ ਫਿਰ ਓ ਮਰੇ ਸੱਪ ਵਾਂਗੂ ਜਿਹੜੇ ਆਕੜੇ ਨੇ ਉਹਦੇ ਹੀ ਸਭ ਨੂੰ ਚਖਾਉਣਾ ਨਹੀਂ ਸਵਾਦ ਹਾਰਦਾ ਓ ਪਿੰਡ ਤੇ ਆ ਸਾਰਾ ਗੈਂਗਲੈਂਡ ਬਣਿਆ ਤੂੰ ਆਖਦੀ ਏ ਜੱਟਾਂ ਸ਼ਹਿਰ ਗੇੜਾ ਮਾਰ ਜਾ ਪਿੰਡ ਪਿਆ ਸਾਰਾ ਗੈਂਗਲੈਂਡ ਬਣਿਆ ਤੂੰ ਆਖਦੀ ਏ ਜੱਟਾਂ ਸ਼ਹਿਰ ਗੇੜਾ ਮਾਰ ਜਾ ਲੱਗੇ ਪਿੰਡਾਂ ਵਿੱਚ ਪਿਆ ਵੀ ਬਾਰੌਲਾ ਪਿੰਡ ਇੱਕ ਲੱਗਦੇ ਦੀ ਨਿੱਤ ਦੀ ਦੀਵਾਲੀ ਆ ਰਾਤੀ 12 ਵਜੇ ਤੱਕ ਹੁੰਦੀ ਠਾਠਾ ਨਵੀਂ ਬੰਦੇ ਖਾਣੀ
Okay, that's enough. That's enough. Cool. Welcome to the stream. Another lead code stuff. Okay. Question 3477. You are given two arrays of integers, fruits, and baskets, each of length n, where fruits of I represents the quantity of the ith type of fruit, and baskets of j represents the capacity of the jth basket. From left to right, place the fruits according to these rules. Each fruit type must be placed in the leftmost available basket, with a capacity greater than or equal to the quantity of that fruit type. Okay. Each basket can hold only one type of fruit. If a fruit type cannot be placed in any basket, it remains unplaced. Return the number of fruit types that can remain unplaced after all possible allocations are made. So, for example, fruits are the quantity are 4, 2, and 5, and baskets are 3, 5, and 4. So fruits 0 equals 4 is placed in baskets of 1. Basically, we accommodate 4 here. We could have accommodated 5 here and 4 here. Number of fruits. Okay. Each fruit type must be placed in the leftmost available basket. Oh, we can't do that. And I mean, I cannot place 4 here and then 5 here. Okay. In the leftmost available basket, fruits 1, 2 is placed in baskets of 0, and fruits 2 is placed cannot be placed in this. Since one fruit type remains unplaced, we return 1. What? Okay, fruits 3, 6 and 1. So 3 can be placed in 6. 6 can be placed in 7 and 1 can be placed in 4. So output is 0. So this feels like an n square solution, right? Since the size of these two arrays are same, we simply do n square. So for I equals 0, I is less than n, I plus plus, find a fitting basket for fruits of I. For int j equals 0, j is less than n j plus plus. If baskets of j is greater than or equals to fruits of I, then these amount of fruits can be fitted into this basket, right? So simply baskets of j, I'll just say 0. Correct? And then break. If j equals n, then count plus plus, return count. So for every fruit, we are checking if a basket fits, then put those fruits in that basket. And we basically say that the capacity of that basket becomes 0 because we cannot put mixed fruit in a single basket. Only one type of fruit can be fitted in a particular basket. Right, so that becomes 0 and then we break immediately. But if j reaches n, it means that there was no basket found, correct? Then we increase the count, which means that this fruit type wasn't placed, correct? Let's see if this works. Wrong answer. 4. Okay. Then 2. Oh, I did a poo-poo here. Okay. Nice. Perfecto. Problems. Let's do more bit manipulation. Integer replacement. Given a positive integer n, you can apply one of the following operations. If n is even, replace n with n by 2. If n is odd, replace n with either n plus 1 or n minus 1. Return the minimum number of operations needed for n to become 1. Interesting. Interesting. Replace n with 2. And acha, okay. So while n, we can simply check if it is even, else n equals. Now n by 2 is expensive, right? I think if I take a look here in bit manipulation tricks, get bit, set bit, clearing bits, multiplication. Multiplication by 2 to the power of x. If division, I think we just shift to the right by 1, I think. $35. I think so. We just shift right by 1 bit. So when n is even, n equals n right shift 1. If n is odd, then okay, there was one Brian Kernighan's algorithm, right? The famous algorithm to find the number of set bits. The main idea behind this is that when we subtract 1 from any number, it inverts all the bits after the rightmost set bit. Okay, for example, the rightmost set bit also gets inverted along with the numbers right to it. Correct. Okay, so should I do DFS here? Basically go in both ways and just check. Or is there another way? Let's see. Let's take this input. So okay, let's take this input. 7, right? Now 7 is odd, right? 7 is 1 1 1. What is it doing? He's doing plus 1. Okay, interesting. If I did -1, this becomes 1 1 0. If I did +1, it becomes 1 0 0 0. Now this is how much? 4 plus 2 6. This is 6, this is 8, this is all 7. Now this is 6. I just simply divide this by 2. So right shift all of the bits by 1. This becomes 3. Now this is also, this becomes 1 0 0. This is odd again, so I can do either, this was 0 1 1, right? So I can do either +1, which is 1 0 0, or I can -1, which is 0 0 1. Correct? This is 4. No, this should be 0 1 0. What the fuck am I doing? 0 1 0 becomes 2. Now this is even, so right shift. This is also even, so right shift. This is odd, so just -1. So when 1 is remaining, just say -1, right? Okay, and this is 2, so I have to divide this, so this becomes 0 0 1. This goes 0. Now here 8, this was 8, then 4, then 2, then 1, then 0. Now let's see how many steps each path took. So this is 1 plus 2, right, plus 3 plus 4 plus 5. 4 how? You do 7 plus 1 8, then 8 7 8 4 2 1. Oh, okay. What? One operation, second operation, third operation. Oh, to become 1. Okay. To become 1, not 0. To become 1, brother. So to become 1, this is also 4, this is also 4, so it doesn't really matter much. But the point is, if there is an odd number and then all of the bits are 1, should I check that? If all of the bits are 1, then plus 1, otherwise minus 1. I don't really know, man. Let's take a look at the solution, man. What is not so obvious is what to do with odd numbers. One may think that you just need to remove as many ones as possible to increase the evenness of the number. Okay. See, both this remove the same number of ones, but the second way is better. So we just need to remove as many ones as possible. Doing plus 1 in case of a tie, not quite. The infamous test with n equals 3 fails for that strategy. So the logic is, if n is even, half it. If n is 3 or n minus 1 has less ones than n plus 1, decrement n, otherwise increment n. Okay, n minus 1 has less ones than n plus 1. Else, if n is 3, integer dot bit count n plus 1 is greater than integer dot bit count n minus 1. Of course, doing bit count on every iteration is not the best way. It is enough to examine the last 2 digits to figure out whether increment or decrement will give more ones. Indeed, if a number ends with 0 1, then certainly decrementing is the way to go. Otherwise, if it ends with 1 1, then certainly increments it is at least as good as decrementing. If n is 3 and n right shift by 1 and 1 is 0, We could have just done n and 3 equals 1 for that if condition. 3 is 1 1, right? Else Wow. If n and 1 is 0, JJ Shiny Forehead, hello, what's up? N right shift by 1 and 1 is 0. So let's keep this. Can I just change the function definition? Oh no. Use test case. Yeah. Okay, cool. Nice. Okay, so I'll just take a 10-minute break. I'll be back. I basically forgot something that I needed to do. I'll be back in 10 minutes. Um, so, meanwhile, maybe I can share some YouTube video. Let's see. Yeah. Meanwhile, chat can watch this. I don't know. Cool. I'll be back in 10 minutes. I think it's time to race. Okay, so career F1. Yeah, let's do Monza 1966. Yeah, let's do this one, man. Soft tires. Let me just check if my stream is good. I think it's good, man. Perfect. Whoa, 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 whoa. Oh no, my bad, brother. ये कार ही घटिया भाई. Let me get the best F1 car, man. Exhaust time attack. Race weekend. This one. Time attack करना चाहिए था पहले, just to see what the track is. This will be difficult. क्या घटिया कलर शेड में. Yo, 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 yo. I'm back. I'm back. Okay. Let me just. Perfect. Sorry for being away. Okay. Back to leetcode. Yep. So this question is done. Next one. Binary watch. Let's try this. A binary watch has 4 LEDs on the top to represent the hours 0 to 11 and 6 LEDs on the bottom to represent the minutes. Okay. 0 to 59. Each LED represents a 0 or 1 with the least significant bit on the right. Correct. For example, the below binary watch reads 451. 451. Okay. Given an integer turned on, which represents the number of LEDs that are currently on, ignoring the PM. What is PM? Aja. Return all possible times the watch could represent. What? Aja, given an integer turned on, return all possible times the watch could represent. You may return the answer in any order. The hour must not contain a leading 0. The hour must not contain a leading 0. What the fuck? For example, is not valid. It should be 1. Okay. The minute must consist of 2 digits and may contain a leading 0. Okay. Okay. So the minute is always 2 digits, but the hour is either 1 or 2. Okay. So the point is turned on 4 LEDs and 6 LEDs on the bottom. Okay. 4 and 6. So basically there are 4 LEDs here. These represent hour. And the minutes, there are 6 LEDs, right? So 1, 2, 3. Let me just move these to the side. So 1, 2, 3, 4, 5, 6. 0, 1, 2, 3. Correct. Now the input is number of turned on LEDs. N equals, let's say first input is turned on can be at max 10. Okay. Let's say N is 3. So any of these 3 LEDs can be turned on at any given time. Seems like a DFS problem, right? So first I'll take one LED. I mean, the point is either this can be 1, right? Then at this point N becomes 2. Then this can be 1. At this point N becomes 1, or this can be 1. When 3 are 1, I am out of turned on LED, so this is a valid answer. Otherwise I backtrack. This can be 1, right? Then this is a valid answer. I backtrack again. Correct. Something like that. and total there are 10 bits, correct? Okay, if there are 9 turned on, why is this empty? There could be okay, makes sense. So this and this integer should be in separate things, right? Int hour initially is 0, minutes initially is 0, dfs hour, minute, and turned on, correct? Now I have to loop through each bit of hour and each bit of minutes, correct? And this dfs function will simply take hour, it will take current minute and number of turned on LEDs, right? And this can be referenced okay, let's see here again. So my strategy is I will loop through 4 bits of hour, right? Just 4 from 0 to 4. I will set that bit and do a DFS. So if n equals 0, validate and store time. Then for int I equals 0, I is less than 4, I plus plus, hour equals hour or 1 left shifted by I. Now I have used one LED here, right? So I should do a DFS on hour, minute, and n minus 1, correct? Similarly for 0, I is less than 6, I plus plus, minute equals minute or 1 left shifted by I, DFS minute, hour, minute. So my point is, when do I okay, this should be how do I clear nth bit? How do I clear nth bit? ith bit from the clear bit. Oh, easy. Or okay, similarly clear this. Right, and in validate and store time, I simply check if hour uh is what, from 0 to 11, right? 0 to 11. If hour is less than 0, or hour is greater than 11, or minute is less than 0, or minute is greater than 59, then return. Don't store anything. Otherwise, this is a valid hour and minute. And in the if string, if hour okay, string so equals this. If hour is less than 10, hour 0 to 11, okay. Okay, so simply answer is to string hour int to string c, to string plus this, and in minutes, if minute is less than 10, answer plus equals answer plus equals 0 plus to string minute, else answer plus equals to string minute. Now in the answer, I will simply push this to result dot push back answer and return result. Let's see. Oh, this should be void, brother. I'm not returning anything. Pum 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 pum. Let's just see if this is even working. What? Okay, something wrong happened. -1. Oh, this should be and, I think. Oh, fuck. My bad, brother. Yeah. Okay, this should be and. But in test case 2, if I say 9, then what happens? TLE, right? Yeah. So what can I cache here? When it is 9 or 10, how can there be 10 LEDs present? So 4. So basically all of these LEDs, then it's impossible, right? That is not possible. Simplify by seeking for solutions that involve comparing bit counts. Oh. What? What the fuck? Let's take a look, man. Simple Python plus Java. Okay, for every hour. Oh, okay. Crazy. Shit. मैं उल्टी डायरेक्शन में चल रहा था. Fuck, man. So simply हमें टाइम पे लूप करना है. टाइम्स एंड आई मीन आवर्स एंड मिनट्स पे, और देख लो उसके बिट काउंट. अबे यार, इतना आसान क्वेश्चन. शिट मैन. फक. 4 int h equals 0, age 11 12, h plus plus 4 int m equals 0, m is less than 60, m plus plus. Now in bit count, count bits. सी प्लस प्लस में भी होगा यार ये. स्ट्रिंग में कुछ स्ट्रेट फॉरवर्ड 6 लाइन m place back to string. Okay, to string hour plus okay, m अगर लेस देन 10 है क्वेश्चन मार्क, देन इंसर्ट 0, otherwise insert just this colon plus to string m, return result. उसने क्या कुछ क्या यूज़ करा है, बिट सेट 10h दिस, व्हाट द फक इज दिस? टू ओके, नो वरीज. सो इसकी टाइम कॉम्प्लेक्सिटी क्या हो गई? 12 times 60, which is constant. Count bits be constant. So order of analyze, I mean any, order of 1. Correct, order of 1. Yep. Cool. Let's do one more. Convert a number to hexadecimal. Given a 32-bit integer, return a string representing its hexadecimal representation. For negative integers, 2's complement method is used. All the letters in the answer string should be lowercase characters, and there should not be any leading zeros in the answer except for the zero itself. You are not allowed to use any inbuilt. Okay. So hexadecimal number होता क्या है वैसे? I think जैसे कोई number है, we divide this by 16, right? क्या आ गया? 16 times 2 is 32, 48 times 3, 48. 16 times 3 is 48. 48 माइनस किया तो कितने बचे? 8, right? हेक्साडेसिमल भूल गए ब्रदर, व्हाट द फक. 26 is 1a, 16a 10. अच्छा, -1 f. I think 56 in this is 38. अगर ये 58 होता या 59 होता, let's say 59, so इसमें बचते 11. so 11 की सीधी निकल जाती 3b. बेसिकली 16 की पावर 1 times 3, 16 की पावर 0 times b. That is the answer, 59. I think this is the hexadecimal thing. 2's complement क्या होता है, भूल गए ब्रदर. 1's complement क्या होता है? Flip all the bits to add 1 to it. Okay. Do. For negative integers, 2's complement method is used. String result equals empty if num is negative. ये -1 को कैसे लिया है इसने, समझ में नहीं आया. -1, अच्छा. Invert the bits in the positive representation and add 1 to it. Oh, okay. Acha, if num is negative, then num equals invert all the bits in num, which is this, and add 1 to it. सही है. Oh, in the absolute thing, right? This should be abs. Correct है. Pam param pam 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 param pam pam pam. While num int q equals num by 16 r equals num mod 16. अब इसको q को हमें पुश बैक करना है अपने रिजल्ट में, राइट? रिजल्ट प्लस इक्वल्स q की मैपिंग बेसिकली, राइट? गेट हेक्स कैरेक्टर फॉर अ गिवन इंटीजर. char get hex int c या int इसको x बोल दो. if x is greater than 16, 0 to 15 ही represent हो सकते हैं, right? then return nothing. throw exception है basically, right? so quotient जो है टू वाह कि इसमें क्या करा था हमने 59 16 से डिवाइड किया तो 3 आ गया. ये बहुत बड़ा नंबर भी आ सकता है, करेक्ट? अच्छा, हमें रिमाइंडर को कन्वर्ट करना है हर बार, राइट? रिमाइंडर को हमें कन्वर्ट करना है हर बार, ना कि कोशेंट को. कोशेंट इज n. सो दिस इज ऑलवेज लेस देन 16, सो इसको हम हटा सकते हैं. सो इफ x इज लेस देन 10 देन रिटर्न 2 char x, correct? else return a plus x minus 10, correct? Makes sense. And okay, int 2 char c plus plus. Pam param pam 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 param pam 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 param pam pam pam. Oh, num plus 0. Okay. Instead of 2 char, it should be x plus 0. Okay. So simply res plus equals 2, get hex of remainder. Num becomes q. Correct. At the end, return reverse res dot begin res dot end. रिटर्न रेस ही कर दो एक बार, देख लेते हैं क्या सीन है. रिवर्स होना चाहिए. रिवर्स स्ट्रिंग सी प्लस प्लस, यही तो किया था रिवर्स. रिवर्स, अच्छा रिटर्न नहीं होगा, ओके सॉरी. सो रिवर्स रेस डॉट बिगिन रेस डॉट एंड. आई थिंक दिस माइट बी इट. ओके, यहाँ पे फक हो गया इधर. व्हाट द फक, एक्सपेक्टेड दिस बट व्हाट हैपेंड हियर. यहाँ पे एक बार सी आउट नम भी कर दो कि पता तो चले करके हो क्या रहा है. पम पाराम पम 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 पाराम पम 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 पाराम पम 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 पाराम पम पम. ओके समझ गया। शेट, यहाँ पे लॉन्ग लेना चाहिए हमें, एन। ओके इसको ऐसा करते हैं, दिस इज एन, दिस इज नम। इफ एन इज लेस देन 0 देन नम इज दिस, एल्स नम इक्वल्स एन। करेक्ट, कुछ फर्क पड़ा इससे? I think if I flip all of the bits of absolute, तो वो साइन बिट भी हो रही है, राइट? Oh, absolute of n. What the fuck? Pum param pum param pum 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 param pum. How to sign bit कैसे वो करें? More simpler words, find the rightmost bit 1 and from that invert all of the other bits to the left of that rightmost. Find the rightmost 1 bit and from that invert all of the other bits to the left of that rightmost bit. जैसे कि +7 is this. Find the rightmost 1 bit. Rightmost, calculating minus. Flip all the bits. ठीक है. Add 1 to it. Prefix with sign bit. अच्छा. Should this be unsigned? Fuck. Unsigned int कर सकते हैं हम. Yes, I'm the fucking king. Let's go. Let's go. Submit the shit. Wrong answer. 0 expected 0. Huh? What? If n is 0, return 0. Right. Submit this shit again. -2 में fuck हो गया इधर. Okay. FFFDE. What happened here? -2. What? Flip all of the bits, then add 1 to it. Oh, that was bad. That was bad, brother. Yeah, +1, na ki or 1. What? Cannot be represented in type int. Cast to an unsigned type to negate this value to itself. What? unsigned int. Shit. Cast to an unsigned type to negate this value to itself. What? लॉन्ग लॉन्ग ले ले भाई. लॉन्ग लॉन्ग में यार फिर वो बिट्स जो लेफ्ट मोस्ट बिट्स 1 हो जाएंगी, जिससे गलत आंसर आएगा बेसिकली. तो लॉन्ग लॉन्ग नहीं ले सकते इधर. सो समथिंग रॉन्ग हियर ब्रदर. कास्ट टू एन अनसाइंड टाइप में इसको का एक मिनट. कास्ट इंट टू अनसाइंड इंट. अनसाइंड इंट आई. अच्छा ओके. क्या मैं ऐसे कर सकता हूँ? नो. Wrong. तो जो एब्सोल्यूट वैल्यू है इधर, एब्सोल्यूट वैल्यू ऑफ n, इसमें ये आएगी विच फिट्स इन द इंटीजर, करेक्ट. बट इसका नेगेटिव जो है, अच्छा ये सही आ रहा है अब. What? इसको अनसाइंड इंट कर लूँ क्या फिर? मतलब पॉइंट, फिर पॉइंट क्या है उसका? फिर वो पता कैसे चलेगा? आई थिंक यहाँ पे बीच में एक और चीज़ करनी पड़ेगी. अनसाइंड इंट एन टू लिख लेते हैं इसको. n, करेक्ट. n2. हाउ अबाउट दिस? आई थिंक दिस विल बी रिडंडेंट, तो इसको हटा दो. हाउ अबाउट दिस? रॉन्ग आंसर. शिट. अगर n नेगेटिव है, दिस इज नेगेटिव, तो इसकी पॉजिटिव वैल्यू ले ली, फिर उसको वो कर दिया, राइट. n2 गिव्स मी पॉजिटिव वैल्यू, राइट. u int equals n2. u int is this, correct. नहीं, u int ये क्यों है फिर? वाह. ये इसका ये स्पेशल केस है क्या? ये सिर्फ बेसिकली एब्सोल्यूट वैल्यू ऑफ इसकी इंट में नहीं है पॉसिबल. व्हाट? सो दिस, व्हाट द फक? मतलब इसको मैं -1 से मल्टीप्लाई करूँगा तो वो गलत आएगा, मतलब ऐसा. पॉइंट क्या है इसका? कंसाइज C++. अच्छा इसने नेगेटिव पॉजिटिव का चक्कर लिया नहीं. Num and 0xf, what the fuck is this? To convert a number to hexadecimal, we extract the last 4 bits repeatedly since 16. अच्छा हाँ correct. इसमें हम bitman बहुत कम चीज़ें कर रहे हैं. Correct. We extract the last 4 bits repeatedly since 16 is 2 to the power of 4 and map each group to its corresponding hex digit. For negative numbers, convert to 32-bit unsigned using num plus equals 2 raised to the power of 32. What the fuck? If num is 0, return 0. If num is less than this, num equals num plus 2 to the power of 32. What the fuck does that mean? इसको C++ में दिखाओ यार. Hex of num and 0xf. What is 0xf? 0x is hexadecimal. F is I think 15, right? So 1111. हमने आखिरी की 4 बिट लॉजिकल एंड करी है नम के साथ, तो जो भी सेट बिट्स थी वो आंसर में आ गई, राइट? मतलब जो भी सेट बिट्स है वो इंडेक्स हो गया हेक्स का, राइट? वो कैरेक्टर निकल के आ गया इधर प्लस आंसर. अच्छा ठीक है, बट ये बताओ इसमें नेगेटिव नंबर्स का क्या सीन है? हाउ डज नेगेटिव नंबर्स वर्क हियर? इफ एन इज नम इज नेगेटिव देन व्हाट हैपन्स? अच्छा क्योंकि वो बिट में स्टोर्ड है तो वी आर जस्ट डूइंग बिट्स. ओके मेक सेंस. तो ये सब करने की ज़रूरत नहीं है. क्लेवर, वेरी क्लेवर, 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 very clever. Unsigned int num1 takes care of negative number automatically. Unsigned int num1 equals num. Base 16 remainder while num remainder निकाला. If remainder is less than this, else this, else this, reverse this. तो आप कहना चाह रहे हो कि if I don't do this, if I just simply do this, then this should give me the answer. Is it? Wow. Wow. Crazy. सही है. सही है भाई. यही bit manipulation. ओके शुड आई डू वन मोर? क्या टाइम होगा? 1 घंटा 20 मिनट. क्वेश्चन तो ट्रिकी है यार ये सारे बिट्स वाले, बट ऐसे ही सीखेंगे टिप्स एंड ट्रिक्स. अगर इसमें 100 क्वेश्चन कर लिए तो सही हो जाएगा सिस्टम. इसके पैरेलली वो बेसिक चीज़ें भी करनी चाहिए वैसे यार, ग्राफ्स वगैरह, मतलब ओरिजिनल एल्गोस और सेगमेंट्री टाइप थिंग्स. You know what? Let me just pull up one hot lap in Assetto Corsa and then I'll close the stream. Let me check, brother, how to do that. Assetto Corsa. म्यूजिक को बंद कर दूँ. गेम प्ले. हाँ इसमें यार ये वो नहीं होती. ओके नो वरीज. दिस वन करेक्ट. Assetto Corsa transition. Nice. Audio, full audio. Hot lap in Silverstone. Silverstone करते हैं. Let's do Silverstone. Silverstone. Silverstone GP. Where's my controller? Start. Max Verstappen. Share. Shit. Sad. इसको थोड़ा इधर करते हैं. सही है. And we don't need this. Performance pedals, let's keep it here. Okay, restart. Shit. Bad corner. Nope. No chance. Come on, man. Nope. कोई चांस ही नहीं है ब्रदर. बेकार ब्रेकिंग. Nope, nope, nope. Let's do spa, man. Fuck it. Silverstone is difficult. Spa. 2 more laps and then I'm done. Come on, man. Nope, nope, nope. Restart this shit. Where is my ghost car? Shit! Where the fuck is my ghost car? अरे यार पीछे ही थी. Damn. Last try. Shit. That was sexy. Come on. I think that's the record. Shit, yes. Finally. Let's go. Okay, so that was it for today's stream. I'll be back tomorrow. Until then, have a good rest of the day.